In this video, we introduce some basic concepts of DDL, or Data Definition Language, and apply them to SQL Server. We can create objects in the database, such as a database itself, a schema, a table, or other objects. We can drop the contents of a table or drop the structure of the table. We can truncate the contents of a table. To create a new database, we use the command create database. You don't have permission to do this on our server, so I won't demonstrate it here. To know more about these commands, you're certainly encouraged to read the book. You're also encouraged to use a search engine. There are numerous sources for instructions and examples on how to use DDL commands. The first one that comes up when I use Google in this particular search phrase is W3 Schools, which is a well-respected and authoritative source for general information about SQL. However, it does tend to stop when things get a little specific. It also generalizes in a lot of cases, so you may not get specifics that apply only to the particular database in which you're developing. So it's a good place to start. It's a good place to get an overview. It's a good place to solve simple problems. It may not be the best place to get a lot of detail about a particular database engine and what the syntax is for that particular engine. For our purposes, we consider Microsoft sources to be authoritative. Here is the web page for the create table command in TSQL, or Transact SQL, which is the dialect that SQL Server uses. There are slightly different versions of TSQL depending on the version of SQL Server that you're running. You'll notice here that this is the 2017 documentation for create table. You probably want to be careful and try to use the particular resource that applies to the database that you're writing at or writing towards. But you're much better off here to get specifics than you are going to W3 Schools. And again, we're not denigrating W3 Schools, we're just noting that Microsoft is authoritative when it comes to a Microsoft product. You are encouraged not necessarily to memorize this syntax, but to know where to find it and to understand the way it's written. We won't go into it here, but it will help you immensely down the road and in your career if you understand the purpose of the square brackets, the commas, the ellipsis, the curly braces, in the way this syntax is written. Most of us have an inclination to go find an example on another page to solve a problem that we're trying to figure out. But we can also solve those problems in a more general way by learning to read this syntax and applying it. So rather than doing numerous searches that may drag out, that may or may not be correct, learning to read this syntax will help you as a database developer. Here's a very simplified example of the Microsoft syntax to create a table. At the top, we see that the words create and table are necessary. We see that inside the square brackets, is an optional construct, a schema name followed by a period. Then we see that the table name is required because it's not in square brackets or any other delimiters. Then we see that in parentheses, we must provide one or more sets of column names and data types, optionally followed by a size in parentheses. We see that the square brackets then delimit an optional part of the construct, and the parentheses delimit a set of arguments separated by commas. So we can learn a lot just by learning how the documentation is written and what the delimiters mean. At the bottom of the slide is a more specific example. We are creating a table called tbook. The schema name is DBO. Now the square brackets mean something different here. The square brackets here are delimiters enclosing the name of the schema, enclosing the name of the book, enclosing the name of the column, and also enclosing the name of the data type. So the square brackets in this example at the bottom do not mean the same thing as the square brackets in the documentation syntax at the top of the slide. If we don't have any spaces or other special characters in the names of these objects, we don't necessarily need the square braces. So you will see for the most part when I write DDL, I do not provide the square brackets because I do not as a rule put spaces or other control characters or special characters in the names of the objects that I create. In this example, we left out several things. We omitted the definition of the primary key. We have the column name, book ID, but we're not telling SQL Server that it is any kind of key. We also left out the definition of any natural key by creating an index value. And we also neglected to tell SQL Server that book ID would auto-increment as we added records. So this is a very simple example just to illustrate a very simple syntax. The concept of a schema is interesting in database development. In general, it means a logical grouping inside of what we think of as a database. If you log into SQL Server on our classroom machine, you will see numerous databases all in a folder called databases. You'll see your database in there. You'll see a database that I use in there to demonstrate concepts. And that is what SQL Server thinks of as a database. Now inside of that, I can create a schema inside of a database to serve as a logical grouping for objects in that database, logically grouping tables together. There may be a schema for accounting, a schema for manufacturing, a schema for human resources if I was modeling a company. Or I may choose to have each of those individual logical groupings in their own database. It's up to me as a database designer how I choose to handle that. Now if I refresh this, I don't have any tables, but I can use this new schema to create a table down the road, which I will do for you in a few minutes. In SQL Server, if you create a table without specifying a schema, you get the default schema DBO, which stands for Database Owner. we generally leave that schema alone. We don't change the configuration of that schema. We don't delete it. And we understand that it is the default, so we make sure that it's there. Now, there may be some security reasons to alter permissions on it. There may be some security reasons to hide it or not put anything in it. But in general, we leave it alone. So if you're in doubt, feel free to put your default tables. You can create tables in the DBO schema, but don't delete the schema and don't change too many permissions on it unless you're sure what you're doing. Let's assume there's a scenario where we already have in the DBO schema a table named book. We can also create a table in the foo schema with the same name. So we see from this that a table name in a database is not unique, but a schema and a table name together are unique. Does it get confusing? Well, certainly it could, but you must study the database carefully and think twice about what your table names might be and what your schema names might be, with the understanding that a table name can be repeated across multiple schemas in the same database. In this example, you can see that we specified foo as our schema name, and we're creating a table called book. The implication here is that there could be other tables called book or tbook in other schemas in the same database. When you get a little bit broader and you move beyond SQL Server and to look at other platforms, you will see that a schema has different definitions. From a total theory perspective, the only thing in a schema is tables and associated constraints. We don't consider queries or stored procedures or permissions or other objects to be part of a schema. However, if you look at SQL Server, you can see that's not the case. So I'm not going to go into too much detail about other RDBMSs and other DBMSs, but suffice it to say that when you move to MySQL or you move to Oracle, you will see a different definition for the word schema, and when you begin doing research on database theory, you will see another definition for the word schema. As far as we're concerned, a schema is what SQL Server thinks it is, and a database is what SQL Server thinks it is. I put this here because we like to refer to SO periodically. SO, Stack Overflow, thinks that there is a lot of interesting talk about schemas. You can see this question. The question is titled Difference Between Schema/Database in MySQL. This question has been voted up 197 times, which is a lot of votes. Meaning it's a popular question and people think it deserves to be discussed and it deserves to be answered. The answer, or one of the 7 answers for this question, has been upvoted 236 times. We see then that even in the world of Stack Overflow developers and aficionados and computer nerds, there's a lot of interest in what a schema might be. Getting back to tables again, I want to show you that here is a, for lack of a better term, full-blown table. A table with an index, a table with a natural key, a surrogate key, a primary key. I just want to illustrate to you that I have this kind of object in my database. You don't have it yet, but you will. And then on the next slide, I want to show you that once I've created that object, however I created it, I can script it. And this is a powerful tool that SSMS provides. So here's a good reason to have SSMS in your toolkit, even if you don't use it a lot. Because once you've got a table created, it's very simple to right-click on the table, select Script, select Create, and then target that script to a new query editor window, and you have a complete working script that reflects everything in that table structure. No data, but you get column names, data types, and you get constraints. So it's a powerful tool to write DDL for you. You can learn that, you can use that DDL to learn what the syntax looks like, and you can build on it or enhance it to use it in other applications. So here is the complete script as generated by SSMS for a table called author. I am going to copy that script right out of the slide, go back to SSMS, and I encourage you to follow along. You're going to have to change that use statement to point to your particular database. So if you haven't logged in yet, log in as your own student credentials that were provided to you on Blackboard. They will not be repeated here for security reasons. And once you've changed that using statement, you can execute this code and it will build that author table for you. I'm going to refresh the tables folder, and there is my table. The table has a primary key. The primary key is the identity specification. It will be indexed automatically. The table has a natural key called last name and first name. There are the columns in the natural key. And all this was done for me by this script that was generated by SSMS. So I had created a table somehow, and after creating the table, whether someone gave it to me or I created it in another way, I used SSMS to generate a script. And I could send you that script. I could send a customer that script. I can use it in the future to create that table. On the following slide is another script, and I would like you to grab that script in SSMS. Open another query window. We still have the script for the author table in one query tab. We have a new query tab. Paste in that second script to create the book table. Notice we are using the DBO schema, which is our default anyway. Run that script after editing the use command. And remember, if you highlight something and you click execute, the only thing that runs is what you've highlighted, which is frustrating and confusing until you get used to it. So if I highlight that database name and click execute, I get a cryptic error message because I know this script is correct, but I accidentally highlighted part of it instead of unhighlighting all of it. And once I've unhighlighted it correctly, it creates the second table. I look at the table folder, and I have book and author. If you look more closely at the book script, you'll see that it adds a foreign key to that table that points to rows in the author table. In other words, there is a foreign key in the book table that references the primary key in the author table. Every book has an author, so syntactically, semantically, that makes sense. I will not ask you to write this from scratch. I will not ask you to do this kind of thing. on an exam or on a homework, I think you're okay letting SSMS do it for you. If you have occasion to do this manually over time, you'll have references to refer to, you'll have SSMS to refer to. So we're not going to get too deep into writing DDL. I just want you to know what the capabilities are and where to go to get help if you need it. At this point then, we should have two tables, an author table and a book table. The book table contains a primary key, a foreign key pointing to the primary key in the author table. They're both in the default schema, which is DBO. And let's go off on a little tangent for a moment. Just as an aside, I want to point out that we can script an entire database using SSMS. Immensely powerful stuff. I can script all the tables and other things in the database as well. All I have to do is right-click on the database, select Tasks, and select Generate Scripts, and I'm off to the races. If I want to send you an entire database, this is one way to do that. I'm not going to do it here, but I encourage you to experiment with this and look at the power of this tool. This is not a substitute for backing up a database by any means. Backups are much quicker, but this is a way to get a schema or some object out of a database for transmission to another customer or for a temporary backup in some circumstances. You can also back up all the data in a script. This would be overwhelming in a database of significant size. You would create a text file that probably wouldn't fit in a Windows file system. But if the database doesn't have an overwhelming amount of data, this may be an opportunity to write or generate a script that creates database objects and populates the tables with whatever data happens to be in the database at that time. Getting back to schemas again, we can create a second schema. You can see in this case I created a schema called foo. I'm going to grab that code, open a new query window, create schema foo, execute. Do you see it here? No, but I can use it to create a table and then it will show up in the part of the table name. What we'll do next is take those same scripts that we used earlier and make a simple edit, changing the schema name from the default DBO to foo, and re-execute those scripts to get two more tables. This is to illustrate the fact we can have the same table name in different schemas in the same database. Here's the book table. We can't create this first because it references a foreign key in the, it contains a foreign key referencing the primary key in the author table. And so we can't create the book table first. The way we're doing things now, there are ways around that, but we're not going to do that here. We need to create the author table first. Now all we have to do is click Control F for find, and then drop down the second window and substitute DBO. Type in DBO and then type in foo. Now this will replace all occurrences of DBO with FOO, and if we select replace all, it should go ahead and change all of those DBO values to foo. Now I probably want to unselect DBO here. We'll see what happens. 5 occurrences, good. It found 5 occurrences of the letters DBO. It replaced them with FOO. We can visually verify that. There's one right there. And there will be some at the bottom. There's some more. And that lets us run the same script, but creating the same table in a different schema. Just make sure you've unselected everything, click execute. Now refresh your database. There's a table called tauthor, but it's in the foo schema. You can see they have the same table name, but they're in different schemas. And let's go back and do the same thing with book. Here's book. We are going to do a Control F again. Drop down the replace window. Type in DBO and make sure foo is in the replace. This is a little bit counterintuitive to me. I think this could be more friendly. I'd like to know that the top window is fine and the bottom window is replaced without having to hover and guess and search, but it is what it is. And then if I hover over here, what I think is a very cryptic icon is revealed to be replace all, and that should have another 5 occurrences or so. There's 5. So I've rewritten this script to create the book table in the foo schema. You can ignore the squiggle. Click execute. Refresh the tables folder. Refresh the tables folder. There it is. I have a book table in the foo schema and a book table in the DBO schema. This is perfectly okay. You may have a requirement or a programming rule at the company where you go to work prohibiting duplicate file names across schemas in the same database. You'll have to see what other people are doing in your place of business. It makes logical sense to use the same name for information that's represented. Sorry about that, we had a little hardware problem. We are back now. We ran a script to create author table and book table in two different schemas just to illustrate that we could do that. And to finish our presentation, we see that we can use the truncate command to very quickly remove all the rows in a table, preserving the table structure. So all the columns remain, the constraints remain, the table name remains, but we lose all the data. Now this has a downside. Because it is so quick, you cannot recover that data. Or let's say you probably can't. There's always a way around these things, but for the most part, let's assume that you cannot. However, if you use drop, you can drop or delete the contents of the table and probably have a much better chance of recovering it. That also, however, removes the table structure itself. You'd have to recreate that table using another script or manually before you can put the data back into it. And when you're done with the schema, you can use the drop command to also remove the schema. So we see that the drop command can be used to remove multiple objects in the database, making it a little scary. In all the work with select queries, we didn't have a worry that things we were doing might be destructive. All we were doing was reading information from tables. Then we moved on to insert, update, and delete queries, which didn't remove table structures, but may or could remove information or edit information or insert information into tables. So those are considered destructive queries. Now we're looking at DDL commands, which could remove entire tables or the entire contents of tables with one line of code. And a huge exposure that you have when doing this is that if you are in SSMS, you can be logged in multiple times to different databases or the same database server using different credentials. And that means that a delete command or a truncate command or a drop command that you execute may have different behavior based on the permissions under which you are logged in. So the moral of the story is be very careful when using SSMS or any tool that you understand the credentials that you use to access that server, and you understand what happens when you run all the commands that you run, because we are doing things that are destructive and could cost you a lot of money or time trying to restore that data down the road when you realize that you were logged in using different credentials than you thought. Our last topic in this presentation is the sequence object, which is an interesting tool that can be used to generate a list of numbers, somewhat akin to the auto number or auto increment fields that we use for primary keys in our tables, but external to a table. We don't need a table to create a sequence. Here I have provided you with a little bit of SQL. Let's grab that code. And let's go back to SSMS, and we don't need anything that we have here, so let's just do close all. New query window. Let's get ourselves back to a database just to be sure where we are. Whoop, I guess I'm not where I think I am. Now I'm where I think I am. So if I try to run this, I'm told there's already a sequence in the database. Not a problem. Can we drop the sequence? Highlight the code, click execute. Good. I can create the sequence. No problem. I don't think that was a problem that you had since you hadn't created a sequence yet, but you can see that since I already had one, it was not an issue to get rid of it. And then if you look under the sequences folder, under programmability, you should see the existence of that sequence. We haven't looked in programmability. There he is. Remember, instead of using the drop command in a query window, I could right click and select delete since I'm in SSMS. We see two ways to do that. We can do it programmatically by writing the drop statement. We can do it using the GUI by right clicking and selecting delete on the sequence. Once we have a sequence, we can write queries against it. We can do a select on a sequence object. So I could grab perhaps these 3 lines of code. Copy. And just put that in there. That runs 3 different queries. The first attempt gives me the first value in the sequence, which defaults to 1 since I didn't specify when I created the sequence. The second select gives me a 2, the third select gives me a 3, and you can see how that would continue on. It's to generate sequential values for use in other applications in your database. And you might ask yourself, can you go negative? Yes, you can. In this particular case, you can see that the first value I get is a very big negative number. Now, if you would like to email me and explain the significance of that really big negative number, I will give you extra credit. Why do you think we need a sequence? In some cases, you may have tables that just can't deal with keys that are out of order or keys that are not in sync with other tables. Therefore, you can use the sequence to drive primary keys for multiple tables in the same database, or even in different databases conceivably. You can also have a sequence start over. We didn't do that in our example, but it is illustrated in the book. What if you only need a sequence from 1 to 10? You can define the sequence that way, such that when it gets to 10, it starts back at 1 again. What if you have a table that does not have an ID field? You don't have the capability of adding an ID field because the table is already in production across distributed customers, and perhaps it's simply not possible to go in and make a change to all those customers because you would break their applications. You can create a sequence and behind the scenes generate primary keys or identity values using that sequence because it is external to all the tables and you would have total control over it, even if you didn't have control over the design of the tables in that database.